Hello there, my fellow mathletes. Welcome back. We're looking at question number 2 on the Hypatia contest from 2008. So just 3 parts to question 2 here, an A and a B and a C. Let's see what we've got. Determine the equation of the line through the points 7, 8, 9, 0. Okay, this shouldn't be too bad. This is sort of grade 9 stuff. Equation of line. They didn't even specify a particular equation of the line. So we have a range of possibilities. We could have things like standard form, y-intercept form is popular, x-intercept form. These are all great ways to do it. They probably would even accept vector form, although for the most part that's beyond what we expect of the high school curriculum. So, you can either pick your favorite form, or you could say, I wonder where they're going with this. It's a Hypatia contest. There's going to be multiple parts. How about we look and see, are there any other lines they've got, and are those lines in a particular form? Because that might help guide me, make my work in A actually be a little more meaningful later on. Certainly something to think about. And if we take a look, not even just reading, just scanning the page for other lines, we've got another line here, and this is y equals 2x minus 10. So they're looking for y-intercept form, or not they're looking for y-intercept form, but they later give us something in y-intercept form. Y equals mx plus b. So let's go for that for our line in A. Okay, we don't have to, but we choose to because maybe it will help us later on. So we've got A was 7, 8, and B was 9, 0. I'll just make sure I've copied that correctly. Yep, 7, 8, 9, 0, okay. And we're going to give the equation y equals mx plus b. Okay. Now, just something I was thinking about here. B, we can see B lies on the x-axis. So actually, you might have said, well, it's going to be really easy to do mx minus a, which is the x-intercept form. This is y-intercept form, very common one. Y equals mx minus a is the x-intercept form. So it would look like this we get for free because we have the x-intercept. Just something to think about. Might have made your life with A part a little easier. And that's just an observation I just made, but I'm going to stick with my y equals mx plus b because that's what I said I would do. So m, we calculate m by rise over run. So that's going to be the difference in the y-coordinates. Doesn't matter what order, just as long as we keep the order. So now we're doing b minus a, sort of. And then the difference in the x-coordinates. So 9 minus 7. 0 and 9 go first. They belong to the same coordinate. 8 and 7 come second. So we get negative 8 over 2. So we get negative 4. So now we know our equation of the line is y equals negative 4x plus b. We just need to figure out this b value. So, we know that both A and B must be on this line. Just plug in some points. So, plug in, I'll say B because I like working with with zeros here. So, 0 is equal to negative 4, 9 plus B. The x-coordinate goes where x was. The y-coordinate goes where y was. So, we get negative 36 plus B. So 0 is negative 36 plus b. I would say it's pretty clear from there. B is going to be equal to 36. So y equals negative 4x plus 36 is the equation. I suppose we don't need a box around the b value here. I got a little too excited. Anyway. So this is the equation of AB. Nice little statement summing it up. So there we go. Alright, so that's A. Now 2B. Determine the coordinates of P, the point of intersection of the line, y equals 2x minus 10, and the line through AB. So we're going to use our equation from part A. The way we find a point of intersection is we set the two values equal to each other. So if P is on both lines, then its y-coordinate must satisfy both equations. And its x-coordinate must satisfy both equations. So it'll be the same y, the same x. Now we have equations for y. Negative 4x plus 36 and 2x minus 10. That was the other formula we were given here. Okay, and it's the same x value in both of these equations. So now we can rearrange and solve for x. I'm going to bring the negative 4x over. So it'll be 6x, 2 plus 4 to cancel out the minus 4. We get 6x. 36 plus 10, we get 46 on this side. And then divide by 2 at least, we'll get 23 is 3x. Okay, well, we're going to have to accept a fraction. X is going to be 23 over 3. And now, how do we calculate y? Y is 2x minus 10. Really just plug your x into either equation. So we get 2 times 23 over 3 minus 10. I'm going to get 46 over 3, and I'll change it to minus 30 over 3, and that'll be 16 over 3. So y is 16 over 3. P has coordinates 23 over 3, 16 over 3. Okay. Now, because the fractions had me a little thrown off, I was expecting integers. I'm actually going to double check by plugging my x value into the other equation. So we're just off to the side. Negative 4, 23 over 3 plus 36. So that's going to be negative 92 over 3 plus 108 over 3. And yeah, that's going to be 16 over 3. Okay. The x value produced the same y value no matter which equation we put in. I was a little thrown off because I thought we were going to get, with the 46 and the 6 there, I thought that it might go evenly, but unfortunately no, 23 over 3. But that does it for 2b. We've got the coordinates of the point of intersection. And if you want to, of course, at the start you could say things like, set the two equations equal to each other to find the point of intersection, but I would say you don't have to. That's nothing weird, nothing that you really need to justify, but maybe you're someone who likes to write more than I do, in which case, of course, add that in. You might be saved a mark, and I might lose a mark for not having justified something. But as I say, from experience, I would say no, that's not the case. All right, so we just have C part left. We're going to flip the page in anticipation of our C part here. Is P closer to A or B? Explain how you obtained your answer. Is P closer to A or B? Well, what can we do? There's sort of a really nice way to tell which one's closer. And that's to use the distance formula between coordinates. So if you've never seen this before, we'll use the distance formula. We use the distance formula to calculate the lengths from P to A and from P to B, and then we'll compare them. I'm explaining what I'm doing. For those of you who haven't seen the distance formula, the distance between I'll write it this way. The distance between an x1 and a y1, so some point like this, and x2, y2, is given by, and then we get a nice little formula here, the difference in the x's squared plus the difference in the y's squared. Now, why does this work? Well, imagine I had my 2 points like this, and they're just sitting out there. The length that we've got here, this is the length we want. This is the distance. We can use our old buddy rise over run. Rise is the difference in the y-coordinates. The run is the difference in the x-coordinates. But because the x-axis and the y-axis are perpendicular, we get ourselves a right-angled triangle. So our rise squared plus our run squared should be our distance squared by Pythagoras. So that's how that works. A lot of people will have seen that, and if you've seen that, thank you for bearing with me. But They asked us to justify it. I wouldn't explain the distance formula, but I would state it clearly. The distance between this general point and this general point is given by this. Really, it took me a sentence, not a whole lot of time, and they did ask me to justify. So I've explained it. Then I'm going to use the distance formula to calculate these lengths and compare. I state the distance formula. Now it's just calculation. Now it's just getting out my calculator if I need it, that sort of thing. Okay. So the distance from P to A is we need so A is 7, 8, B is 9, 0, and P is 23 over 3, 16 over 3. And these fractions here make me a little nervous, but we'll work with it. We'll work with it. So 23 over 3, by the way, the order doesn't matter because it's going to get squared. 23 over 3 minus 7 squared plus 16 over 3 minus 8 squared. So we'll put everything over 3, so 23 minus 21 over 3, and that'll get squared, plus 16 minus 24 over 3, and that'll get squared. So that's square root of 2 squared over 3 squared, so that's 4 over 9, plus, and this will be negative 8, so negative 8 squared, 64 over 9. And that'll be square root of 68 over 9. We can take out a 2 over 3, and then we'll have a root 17. Okay. So that's the distance from P to A. It looks fine. How about the distance from P to B? I don't want to cram it down at the bottom, so we're going to do it on the other side. I'm not saying this is the only way to do it, by the way. 9 minus 23 over 3 squared plus 0 minus 16 over 3 squared. And put everything over 3, although the 0 doesn't need to be over 3. 9, so that's 27 minus 23 over 3. That'll get squared, plus negative 16 over 3. And that will get squared. And I think PB is going to be the bigger one. So that'll be 4 squared over 3 squared, so that'll be 16 over 9. And then 16 squared, if you need to get your calculator, go ahead. 256 over 9. And now add these up. 6's, we'll leave a 2, so it'll be 262, and then plus another 1, so it'll be 272 over 9. I can bring out a 3, I can bring out at least a 4. 272 divided by 4 goes into, so 24, so it's a 6, and then we've got a 3, so 68. So it'll be, there'll be another 4 that we can take out, and we'll get 17. So it'll be square root 4, square root 4, square root 17. Each of these is 2, so this will be 4/3 root 17. Nice and easy to compare. And I spelled comparing wrong. Comparing, we see 4/3 root 17 is going to be greater than 2/3 root 17. Very nice that the numbers worked out. I don't need to get my calculator out to compare them because 2/3 is a smaller fraction than 4/3, and they're both being multiplied by 17. So PB is greater than PA. That's the distance between them. So A is, so P is closer to A. That's how we should phrase it. So P is closer to A. And there we go. But they asked us to explain how we got our answer. Well, we did. We said we'd use the distance formula. We'd compare the results. We stated the distance formula just in case they think it's something weird and exotic that we shouldn't know, although most high school students should know it. If you didn't know it, now you do. Did our calculations, 2/3 17, other calculation 4/3 17, quite a quick comparison. Haven't had to use my calculator yet this contest. We're going to hopefully keep that going into question number 3. But there we go. That does that finishes off 2C. P is closer to A. Okay, so we're halfway done the contest. Feel free to give yourselves a little pat on the back. and I will see you guys in the next video for question number 3. Have a nice day until then.